Well, question 6 says, test a claim about population mean, and the information given are as follow. Claim says mu is not equal to 6,000. Mean is not equal to 6,000. What is this? Is it the null hypothesis or alternative hypothesis? This is your alternative hypothesis. So null hypothesis says mu is equal to 6,000. Your alternative hypothesis says mu is not 6,000. Alpha is 4%, sigma is 420, and the sample statistic X bar is 6,300. N is 38. Well, we know that our null hypothesis says mu is equal to 6,000. Alternative says, hey, it's not. So we already know that the correct answer is A. It means that we have a two-tailed test. Two-tailed. Quickly graph it. Two-tailed test. So some part of the area is on the left. Let me use the green color, green region. And some other part is on the right-hand side. Well, calculate the standardized test statistic and the rest of them. So let us use our calculator. We just learned how to use our calculator. So what we're going to do, we're going to go to stat. Then we're going to go to tests. So stat, tests, and since it's sigma is given, we are using z-test. Enter. We are using stats. We don't have the actual data. We're just using stats itself. So now, what are the information that we have? Mu sub 0 and k are the same. In this case, it's given as 6,000. Sigma is given as 420. X bar is given as 6,300. And N is 38. And you know that it's a two-tailed test is not equal to. So let us calculate. Let's do the calculation. Very well. My Z is 4.403. So these are the information. By calculating this, calculate. Z is 4.403 and P value is given 1 point. Okay, guys, note that we have negative exponent here. 1.0677619 exponent to negative 5. It means that I have to move this decimal place 5 places to the left side. It means that P is very, very small, almost 0. It's very close to 0. Okay, perfect. These are the information that I have. And now let us continue. What is the standardized test statistic? The standardized test statistic is 4.403 or just 4.040. Round to 2 decimal, that's why I rounded to 40. So if you're not using a calculator, Z is X bar minus mean divided by sigma times square root of A. Okay, how many critical values do we have? We have 2 critical values, all right? Because one of them is on the left, the other one is on the right. So it's not one critical value. You have 2 critical values. How do we find critical values? To find critical values, we have to take a look at the board. To find critical values, we use inverse norm alpha divided by 2. So inverse norm alpha divided by 2. Inverse norm. What is our alpha? Alpha is 4%, so we get 2%. Let's take a look at our calculator. Second bars, inverse norm, alpha is 2%, and calculate. Negative 2.05. So plus minus 2.05. Critical values. So negative 2.05 and positive 2.05. Okay. Is Z inside the rejection region? Is 4 inside the green region? Yes. 4 is going to be greater than 2. So 4 is roughly here. Close to 4. 4.40. So it means that we reject the null hypothesis. So you can say that since Z 4.40 is in the green area, we reject the null hypothesis. It means that we can say that, hey, the claim is supported. HA is supported. HA was the claim. So we fail to reject, no. We reject the null hypothesis, and here it says at 4% significance level, there is enough evidence to reject the claim. No, we're supporting the claim. So this is not this, fail to reject. No, we reject the null hypothesis, and there is enough evidence to support the claim. You could see that using your p-value. As I mentioned before, these are all equivalent to each other. You could use just p-value. P is very small, or use p-value. P-value is almost 0, and almost 0 is always less than or equals to 4%, which is your alpha. So you reject the null hypothesis. Question 7. So this question says, you have a random sample of 89. So n is 89. Just identify the numbers here. Remember that when you have numbers and you see numbers, you have to stop. You have to think about the information that related to your number. So 89, your sample size. Okay, assessment test has a mean score. Okay, this random sample has mean score of 266. It means that X bar is given to us, 266. This test result promotes a state school administrator to declare that the mean score for the state, so the mean score for the state on this exam is more than 260. So remember that here you had a sample and the information about the sample was X bar. Now you are moving on to another number which is related to the mean for the state. It means that 260 is your claimed mu. So in this case, mu sub 0 or your K. It says more than. So you have mu greater than 260. mean score of this test in the state is greater than 260. Now it says, hey, we have a population with standard deviation, which is 33. Very well. So sigma is given to us, 33. Also alpha, which is 11%. Is there enough evidence to support the claim or reject the claim? Remember that the claim and your alternative hypothesis are the same. Okay, the alternative hypothesis is given to us. It says mu is greater than 260. Its complement less than equals to 260. This is your null hypothesis and this is your alternative hypothesis. So this is the first, okay, we're lucky. The first one is the answer. Null hypothesis says mean is less than equals to 260 and alternative hypothesis says mu is greater than 260. Okay, perfect. Before filling out these, let us use our calculator. Let me put the calculator here. Write it down for you. So hypothesis testing for the mean, we go to stat, we go to tests, and since sigma is given to us, standard deviation of population is given to us, we have sigma 33, we use z test. If it's not given, we're using t-test. Okay, so let's turn it on. We go to stat, we go to tests. Now we select our z-test. Okay, we don't have the actual data, we have the stat, information about the sample. K or mu sub 0 is given to us, 260. So this is 260. Well, what is our sigma? Sigma is 33. What is our x bar? X bar is also given, 266. Okay, what else we need? We need the sample size, which is 89. Okay, now your alternative hypothesis is greater than 260. So we have to select greater than mu sub 0 or k 260. Let us take a look at our information. Calculator give us our z is given as 1.72 if you round it, and p is 0.04, 4%. Without going through the rest of these information, by using p-value, since p 4% is less than your alpha 11%, you say that, hey, you reject the null hypothesis. You reject the null hypothesis. Using the calculator, this is our conclusion. Now let's fill out the blank here. It says, find a standardized test statistic. Z, we know that it is x bar minus mu divided by sigma times square root of n. So z is equal to 1.72. Find p-value. How do we find p-value? If we don't use our calculator for hypothesis testing, remember that this is a right-tailed graph, and since we have our z, we use inverse norm for 1.72. Second bars, inverse norm, just in normal. I wanted to use the critical value. So if you use, okay, let me just clear this one. Let's get back to second bars. Go to your normal CDF. Okay, here we go. Let me just reset the calculator for you. Okay, one more time, second bars. Normal CDF, you have our Z, we find the area, so it's 1.72 and upper limit is 100. So note that it's the area to the right. So mu is 0, standard deviation is 1, paste. We get 0.04. 0.04. As you can see, they are the same. Using your calculator for hypothesis testing or just directly following the flow chart to find p-value. You could say, hey, I want to find the critical values. If you want to use the second technique to find the critical values, it was inverse norm of 1 minus alpha. Okay, so p-value, we know that p-value is less than equals to alpha, 4%, 0.04%, which is less than or equals to 11%. So it means that we reject the null hypothesis. We reject the null hypothesis. Interpret your decision. At 11% significance level, so we are talking about the claim. We are rejecting the null hypothesis. Unofficially, you can say that, hey, I'm supporting my alternative hypothesis. Alternative hypothesis or the claim were the same, or support the claim. So at 11% significance level, there is enough evidence to support the claim, which says the mean score for the state's 8th graders on the exam is more than 260.